In the previous video, we looked at an introduction to alkanes, which are the main organic molecule that we start looking at because it's the most basic. They're a saturated carbon, hydrocarbon, sorry, where you have basically just single bonds of carbon to hydrogen and carbon to carbon. So now we're going to focus on a thing called an isomer of an alkane. So an isomer, or a structural isomer, sorry, is a different structure of the same molecular formula. So take this molecular formula here, which is for hexane. Okay, most of us in our heads would have an image of what hexane might look like. But there are multiple ways of structuring 6 carbons with 14 hydrogen atoms. So remembering that carbon to carbon bonds should be single like that because it's a saturated hydrocarbon, and carbon to hydrogen bonds should also be single. But as far as the arrangement, it doesn't have to be a single chain, it can have branches as well. So pause the video now and see how many structures you can come up with for this particular molecular formula. Okay, so hopefully you were able to come up with some examples of this. I've got a rundown now of the different structures you could have come up with. So if we look at the basic one there, we've got a hexane molecule, which is just a straight chain. Okay, so this one's a straight chain. And the rest of them have branching. So if we look at this one here, remembering how we do our naming, we have to select the longest chain, and that's the root of our name. So that's 5 carbons, which is pentane. Okay, and then you look at the substituent groups, the bits that are substituted on. That's why it's called substituent, and that's 1 methyl group there. So we call that methyl. And then we need to make sure we've numbered the carbons appropriately. So 1, 2, 3, 4, 5, going that way. Otherwise, you'd end up with the methyl group being on the 4 position, which is no good. So that means that it's on the second carbon there, so it's 2 methyl pentane. Okay, and so on with the next one. So this one is pentane again. So this one you have to check which the longest chain is. So you could either go straight down the middle here, or you could actually get 4 in a row by going around the corner. But actually it doesn't make a difference as far as where the methyl groups are substituted. They're always on this second carbon, no matter which way you draw them. You can try all 3, and either way you're always on the second carbon. So this one is 2,2 di, and then you've got your methyl, because it's 4 carbons, this time it's butane. Okay. Okay, so those are different versions of the same molecular formula. So we call these structural isomers. And every molecule with lots of atoms would be expected to have a variety of structural isomers. So they have the same molecular formulas, and therefore they would have very different chemistry, potentially,